and Chris Menas for machine learning for
Thank you. Thank you for the introduction. How are you doing, everybody? Good. Very tired? It's already 7. Well, thanks for welcoming me here. It's a pleasure to be back, always in Vietnam. And today I will be talking about a few topics. First of them is going to be TensorFlow for mobile developers. This one is probably better. Done. Very briefly about me. I'm a freelance developer based in Munich. I was born in Spain. That means I speak very fast, but I will try to slow down. If at some point you see you don't understand me, make a weird face, so I will know I'm going very fast. I'm part of the Google Developer Expert Group in Kotlin and Android. If you don't know the GDE, the Google Developer Expert Program, it's sort of a program from Google where people that contribute to some Google technologies are part of. This is my Twitter account. I know here in Vietnam, Twitter is not that popular. We use Salo, right? Instead of Twitter. I have a Salo account, but I don't write anything there. And so I'll keep moving. First of all, how many people here has used machine learning before? Can you raise your hand? Okay. How many of you have used machine learning in production? Can you raise your hand? I use Twitter because it's mostly about jokes and hiking. I saw this in one tweet some time ago. And it says that many people seem to deal with machine learning, and because we are all programmers or developers or working in IT, we like to experiment with the latest technologies and download the latest framework and see what it's about. But when you ask how many people is actually using this in a real application, it seems that we don't seem to find where to apply something like machine learning. Another Twitter thingy. What used to be called an algorithm is now called artificial intelligence. If everything is artificial intelligence, nothing is artificial intelligence. This is similar to when you work at a company and everybody's a manager, when nobody's a manager. I remember a few years ago, I was working at a company, and people that started after university, they were called junior managers. So then you have the junior manager, standard manager, I guess, and senior manager. So who's actually working if everybody's a manager? So same with algorithms and artificial intelligence. Not everything is artificial intelligence, and not everything is machine learning. This is actually part of a book excerpt from a book from Elon Musk talked about this, and it's called Superintelligence. It's a book where it's very interesting. I don't think it's translated into Vietnamese, it's in English, but very easy to read. And they talk about the dangers and the risks of superintelligence. What will happen when the artificial intelligence develops? Maybe we will we program an algorithm to make, let's say, caps, and then the algorithm goes very efficient, crazy, and then turns the entire universe in a machine of making caps and kills us all. Anyway, the book is really nice, and they have also these excerpts here. As soon as it works, nobody calls it AI anymore. It seems we call it AI when we don't understand what it is. But AI has some boundaries, machine learning has some boundaries, and they're easy to understand. Before I keep moving, I'm going to try to contribute a bit to define what is artificial intelligence and what is machine learning and stuff. Artificial intelligence is the science of making a machine smart. And artificial intelligence systems would be a self-driving car, for instance. Or if you have those assistants on the phone, like Siri, or like Google Assistant, those are AI systems. Machine learning is the art of building machines that can learn. We don't train the machine to learn everything from the beginning. We give an initial set of data and an initial input, and the machine is able to create the knowledge. There are different types of algorithms for machine learning. Neural networks is one of them. And then we can even go deeper into the learning. It can be supervised learning. That means when essentially we have a supervisor that is checking that every step is right. We have unsupervised algorithms. That's when we left the machine learning, and that can lead into very interesting examples. Some time ago, I think it was Microsoft, they published a bot in Twitter that was learning from Twitter and talking with the community. They had to deactivate it because it started to get racist. It started to talk about minorities because it was unsupervised. And it was essentially learning what people were talking in Twitter. And Twitter is a very interesting place, right? Everybody can go there and write what they want. And that's one of the characteristics of unsupervised learning. I saw this somewhere in Twitter. I don't remember exactly where. And I don't know if you can read well from. Can you read it? Very well here. Yeah, I'll post the slides later anyway on Facebook or Twitter. Basically, here we have four categories of systems, of software systems in decision making. On the left, we have a rule-based decision system. This is the basic one. We have an if this condition, then apply this thing. If this other condition, then do this other thing. Every programmer can do this. As we are moving to the left, the next one will be a statistical reasoning. In this system, we basically do detection and extrapolation of data. That's something that every programmer can also do, is basically applying some statistical formulas and stuff. As we keep moving to the right, we move into an expertise knowledge. One of them would be machine learning, where we, as mentioned, we essentially train the machines to learn by themselves. And on the extremely right, we will have the AI systems. So building cars that can drive by themselves, assistants, having human-like conversations. Those fields right now require more specialized training and background. Obviously, everybody can get there. It's not about being elitist, but it's something that is decoupling from programming. So it's just not simply programming. It has its own set of tools, books, educational background and stuff. I think always pictures of cats make things easier to understand. This is how a neural network works. Essentially, you label a set of data as of pictures as cats or dogs. You create different levels, and as you put them through the network is able to tell you this is a cat or this is a dog. One of the misunderstandings with the neural networks is that we always see this example with cats and dogs and pictures. But a neural network can be trained to recognize everything that can be serialized and digitalized into bytes. For instance, text, characters, or audio, or anything that can actually be saved in a file. There are a few interesting examples that I will give you later. I was working with a startup in Barcelona that they were developing a system to do sentimental analysis with TensorFlow. That means they were taking some text, labeling the initial text like this is a happy text, this is a angry text, this is ironic text in different languages, creating the TensorFlow network, and then later they were feeding the TensorFlow with some text coming from social networks. So what this company was offering was, well, given a certain company, we will analyze Twitter and Facebook or Salo or whatever social network they're using and take some real-time feeling of what the people are doing about that company. Are they happy about your new product? Are they happy about your new release? Are they complaining about what you're doing? And that was done with TensorFlow. Now, we joked a little bit about things being used in production or not. This image here are companies, products from Google that are actually using TensorFlow. Those products are in production and they have integrated a tensor within their application. You probably know already Gmail with the smart reply where you click and you get 3 options. The spam classification, it has been there for a while. Google Assistant now is getting crazy. I don't know if you saw in the latest Google I/O, there was a conversation between a machine and a human being. And it was very interesting because the human being was saying like, oh, can we meet, can I have an appointment at 7? Yes, you can have an appointment at 7. Oh no, sorry, I cannot do it at 7. Can I maybe do it at 6:30? Yes, it's also open at 6:30. and that was done through TensorFlow. Google Translate is also getting very good now, very efficient. And I'm going to show you some examples. I recorded this with my emulator. I work remotely, that means I can travel and visit basically my entire office. And one of the places I like a lot is Japan. So I go to Japan, I take some pictures, I use Google Photos, and my pictures get uploaded automatically. Google Photos is very convenient, by the way, because they can store as many pictures as you want with no limit. They just increase the quality, so I think for social network addicts, it's very convenient. And you can actually search things on Google Search, but not only by location, such as Japan or San Francisco or California, but if you actually type Japan, it will search on the images, all those images that have a relationship with the Japanese culture, such as sushi, Torii Gate, Bamboo Gate, Castle. You can do the experiment if you have this application and search for something like vegetable, green, building, Vietnam, and you will be surprised to see the quality. Even if you have a couple and you have interacted with your couple and write girlfriend or boyfriend, it will likely show you pictures of your relative being, which is fantastic. So here I'm typing Japan, and it's actually displaying me all the pictures I have on the emulator. That was just a little experiment that had something to see with Japan. And this is actually not geolocation. I just upload the picture, I took a screenshot, and he's just searching and realizing that, okay, this castle might be something that has a connection with Japan, or I think the second row is whale meat. It's obviously from Japan. The smart reply. If you use Inbox or Gmail and you type a response, you will get something like 3 fields showing you a response in a particular language. It doesn't work for all of them. I'm not sure about Vietnamese. But for example, I write regularly in English, German, and Spanish. And this smart reply is able to show me 3 contextual responses based on the language, on the email I have opened, and based on the language I'm using. This, according to Google, is now 12% of all the responses, which is huge. And now, one of my favorites, Google Translate. Now, if you use Google Translate, it's very convenient when you're traveling, because right now you can even take a picture, select on the picture the text you want to translate. So, for instance, for me, obviously Japanese and Chinese is very hard because I cannot write it. But even Vietnamese, you have all these accents, right? Like I don't know which one it is, and sometimes even my keyboard doesn't even have them. So I can take a picture and select the square and say, please translate this. Now, this is an example of how things have improved since some time. The blue line here is the efficiency using the previous phrase-based translation mechanism. This system is a little bit more complex, but essentially it takes one language A, creates a tree in the middle, and translates into the next language. The green color is the efficiency using a neural-based system. That means TensorFlow. Google Translate is right now using TensorFlow. And the yellow one is the efficiency of a human, of a person doing the translation hand by hand, based on the knowledge they have over here. So now if you compare some languages, like for instance, English and Spanish, they're very similar, or French and Spanish, they're sister languages. The efficiency of the neural system is very similar to the efficiency of the human. This is probably not very good news for translators. Are there any translators here? No? Good, you'll keep your job. For languages that are still not very similar, like English and Chinese, you see that there is still a gap. A human is still able to translate better. But this is getting better, and the gap is getting closer. Here is an example of how you can translate this sentence here, that in Chinese means something like, where is the toilet or where is the restroom? Using the previous system, the efficiency was not that good. But now, with the new system, you see that it's a perfectly formed English sentence with perfect grammar. And this is training every day, and it's getting better every day. It's realistic to expect that at some point the Google Translate will take over the efficiency of the human translators. Now, down. I think there should be some sound with this. Okay. Yeah. Now, this is an example using the latest application of Google Translate.
Testing. One. Two.
As you can see, it's taking a language on the frame, each frame is running,
Nice.
and it's translating from one language to another language. I think it's surprising that he's keeping the colors. He's even able to keep the font. If you're using one font or another one. And he's so smart that when you need to make to change lines, it makes it automatically. And important here is that it's running on every frame. It's very fluid, right? It flows. Imagine as a developer, if you need to send every frame to a backend, to a web service, wait until it has been translated and get it back, that would take a long time. You need to compress the image, send it over the internet, wait for the response. It's not possible to do this in real time. It lasts for a long time. I could be video all the time. Good. I'll get back to the importance of having it on mobile and locally. Now, if you have some devices, such as watches or glasses, or you can also use, you have a lot of possibilities, like using the sensor stuff. For instance, I have a watch, and one of the things I do a lot is when I get a message, I just open the application, get one of those contextual responses on Hangout, click, and send it directly to the other person. So I don't need to wait until I'm in front of the computer or I take my phone. I can do it much more efficiently. And now, some surprising applications of TensorFlow. This KMaggie is a proof of concept yet, but essentially it translates from babies into English. The point here is that babies in every country, they react the same. Where they're crying, they cry with the same pitch in Vietnam as in California or in Brazil or in South Africa. When they're happy, they do the same, they behave the same. They don't have this cultural thing still in their minds. So there was a group of researchers that they were recording babies crying or being happy or being hungry and created a TensorFlow model and then an Android application. So essentially you could put your phone to your baby, and if it was crying a lot, you could say, oh, maybe he's hungry. I recommend you to pay more attention before as a father, but as a proof of concept, it was very interesting. And now, my favorite one. If you Google this, recognizing beer with TensorFlow, there is an article written about this topic. Essentially, there was a person somewhere in the world that took the time to take thousands of pictures of beer bottles. I assume he drank them before, and created a TensorFlow model to be able to recognize beer. So, if you're working just doing applications for any company, think that there are heroes out there. Now, we had the discussion of whether cloud versus mobile. Now, why should we use mobile against the cloud? What we have seen before on that video is not possible to do it. We need to do it to compress the image, send it over the internet, wait for the response. Just that would take us a massive amount of data. By deciding to resolve the problem locally, we will achieve less traffic, a faster response, and we can also use the motion sensors. Now, what is TensorFlow? How many people use TensorFlow before? In production? Well, TensorFlow today is an open source library for machine learning. This is the URL here, and is the most popular machine learning framework in the world. There are actually two options. We could use TensorFlow Lite and TensorFlow Mobile. And TensorFlow Lite is going to be the future, as per Google announcement, but right now it's not quite there. It's still beta. The thing is, with TensorFlow Lite, we have a smaller binary size, we have fewer dependencies and a better performance, but it's right now a developer preview. Google doesn't recommend to use it for production. And right now supports as well a limited set of operators, and not all the models will work. Things we can do with TensorFlow. Well, we can train our models on Macintosh and Windows on a GPU server or on a GPU or TPU server on the cloud. TPU stands for Tensor Processing Unit. It's just a hardware that has been customized to train tensors. And we can predict them. We have an SDK for Android, iOS, and Raspberry. This is Cypher 10 is a benchmark that tells us how fast can we train the models. I think the interesting part here is that what we need with 16 CPUs, which is 4.8 hours, we can achieve it with one GPU. So GPUs are not only to mine bitcoins, you can also use them to train models and video games and other things. This is a list of products that are using TensorFlow on their productive application. That means on something that is live and is generating revenue and money. Many companies here, of course, Google, Airbnb, Airbus and Military are always there, Twitter, so it's not anymore something that is only on the theoretical realm. Now I want to go first through a concept developed by, this is the Twitter account of a guy called Jufen. He's a developer advocate for TensorFlow. And he explains how to make in 4 or 5 hours move from having a concept into having actually an app for Android that is able to predict a model. So first, we need to gather a lot of training data. My question for you, imagine you want to gather many images from this cat over here to train the model. What would you do? Do you have any ideas?
Parse.
Would you?
Parse.
Parse?
Parse from the web is scroll data.
Like from Google Web, for example, or that's a good option? Something else? That's a good option, but I think it might take more time, because you need millions. That's going to take some traffic. One thing you could do is to take video. Because taking video is essentially, each second is 24 or 27 frames, depending on the format you have. And you could start doing something like this. You could have a bottle, put it with different backgrounds, put it in different places. If people see you recording this in a public place, they would think you're a bit crazy, but don't matter. You could go to the street and put it with different light conditions. That's very important when it's cloudy, when it's not cloudy. And then essentially each second gives you 27 images. So you just can take thousands very easily. Now you have the images. You could use a software such as FFmpeg. It's open source, free, to take all the images and separate them. And later upload them. This model works not creating them locally but on the cloud. And you could upload them to Google Cloud Storage. And I don't know how many people knows here the machine learning engine from Google. But it essentially allows you to train things and train models based on whatever you have in a bucket. So it's very convenient. If you don't want to go through all the set it up on your computer, you just can upload it to the cloud, go to the machine learning and say, hey, train me a model from this thing I have in Google Cloud. Now, before we move forward, I want to show you also how a neural network works on the inside. Imagine you have this puzzle here. This puzzle is from Escher. It's I think he's German or Austrian. I think he's a crazy German guy that makes these sort of patterns here. Like it's people that is always going up in a stair and things. He plays a lot with perspective and infinity and things that never finish. So if you have a puzzle like this, many pieces, how would you solve it? How would you put it together? How would you start? Any ideas? We could start finding patterns. Patterns can be colors, patterns can be shapes. In this case, we only have 2 colors, right? So we could start putting like white and the rest of the things together. Then step by step we can keep moving. We can see that here we have 2 different patterns for the roof. Some of the roof structure is different, so we could start step by step collecting them and put them together. here we see on the stairs that it's you have different shapes. Some of them are perpendicular, some of them are parallel, and we could go step by step trying to find them, put them together, until we reach out something like this. This example was particularly difficult because you only have 2 colors. If you have more, it's easier, you have more patterns. But this is essentially how the neural network works. It tries to find patterns and give you an output. They say, yes, this is I was able to almost finish the puzzle with 98% of certainty. I think this is a puzzle from Escher. Or what neural networks do, they tell you this is an apple, this is a cat, or this is a dog. Now this is how a neural network works in a diagram. Essentially it takes a raw image and classifies it, and it does it through 48 different layers. There are many mathematical details. It would take a long time to go through all of them, but you could ask yourself, is 48 layers too much? But to give you some, that was the first question I had. To give you some context, in 2011, a neural network could not have more than 4 layers because it was thought that a computer could never compute it. And now it's 48. And each level adds a new layer of complexity. So now let's say we have trained this model using Google Cloud Machine Learning Engine. This is about 84 megabytes. It's like a Whopper XXL, super big. How many people here are mobile developers or work with mobile? Okay, if you're working with mobile and I tell you every model is going to be 80 megabytes, you will tell me, good, I'm not going to use your model. Probably, because you need to download it, every new update you need to create a new model. That's a lot of traffic for an application. Well, fortunately we can optimize it for mobile phones. There is a process called quantation that basically divides by 4 the size. It moves from 84 into 2021. And a model is a file of digits of 16 bytes. Quantizing basically divide it and take only 4 bytes, and you will say like, well, but it's not going to affect the performance of the network, right? Well, the networks are done so they can tolerate this fuzzy input. They have a lot of garbage for an increase in performance that is not that big. It makes sense if you're using it on a server, the performance might not be that thing, but on a phone you need it to be small. And by dividing the size by 4, we decrease the accuracy and the performance of the model by 4%, which is very good for the size. Now, if it's still too much, you could use another inception version, another neural network version. The first version, the latest one is 4. The first one is only 7 megabytes when you have optimized it. For Android developers, TensorFlow increases the APK in 12 megabytes. That's also that maybe you also want to consider. Now we're here. We have created our model, we optimize it for mobile, and now we need to load it into our Android app. Here there are 2 approaches. We could zip it together with the mobile app, or we can store it externally, and every time there is a new update, the application will go to Firebase or to Google Cloud or to Amazon and say, is there any new model? Has anything changed? And you could download the latest one. I think this first approach, it's claimed that it's more secure, and it's better because you don't have the model anywhere externally, so you can protect the business intelligence of your company. But for all of you developing Android, Java is essentially open source. If you have an APK, it takes like around 1 minute, depending how much time you need to type it, to uncompile the APK and extract everything. So it doesn't make that argument for me is not that relevant. The other one is better because also anytime you have any update to the model, and that happens very frequently, you want to release a new one. You don't want the user to download the entire app and install everything. It's just the model what you need. The app hasn't changed. Now about TensorFlow. Today it has over 1,000 contributors, over 22,000 commits, and more than 18,000 repositories with the name TensorFlow. That's actually cool. That's how I found HeyMagic. If you type TensorFlow in GitHub, there is many crazy people that have a lot of free time and are experimenting and releasing new ideas with TensorFlow. This is how the community is growing, the interest of the community. You can see that now TensorFlow and machine learning, they do really belong together now. Every increase or decrease in interest by machine learning is very coupled with TensorFlow. From all those developers, how many of you develop with Android? Can you raise your hand? The other ones you develop iOS? Okay. Well, I do more Android than iOS. I have to do both because as a freelancer, essentially you are unemployed every 3-4 months, so you need to learn whatever people ask you for. And I think the building this with Android Studio today is not very easy. It will probably get better. They are releasing new versions every 2 weeks, but right now requires some extra work. You need Bazel to build. Bazel is like a Maven or Gradle. It's a build mechanism. You need to set the binary location in this folder from here, add the project to your Android Studio. Of course, first you need to install Bazel. You need to download it from, basically if you type Bazel install will be the first result on GitHub. The install instructions are not very updated, and if you have Macintosh, you will go through trouble, because if you have one version on Python, it will not work, you need to install a few modules, etc. You need to download the Android SDK, at least the version 23, and the Android MDK, the version 12b. I recommend you to do it with Android SDK Manager. If you do it by yourself, something will probably go wrong because there are so many dependencies and so many things. Then there is this workspace here. You will find something called Path, where you need to update it and include your SDK repository and the NDK repository. Don't worry too much about this. I will post it later so you can have access to it. Then run Bazel with this command. If everything works out, you will have an APK that you can install on your mobile phone. And for all of you developing with Android, you will ask, why don't I download this from Maven or from any other repository? Well, you can. There is a pre-compiled version that you can download and use. But right now, the conversion between YGB and RGB is less efficient, and the object tracking is not available, which kills a bit the purpose, right? You want to have object tracking. It's one of the main things from TensorFlow. Now let's gonna see a few of the samples that we have from Google. Then we have a classified sample that uses Google Inception, the version 3, to label images. The models are very easy to swap. We get a model from Google, but we can put our own model if we want. There is no label for person. That's very interesting because if I would start right now tracking you with the phone, I would not get person. I would maybe get hair or eyes or glasses. This is true, they have done this thing. And if you click on the value up, you can see